In this video, we're going to look at an area of a sector question that's suitable for those students aiming for a grade 9. The question states that the area of a circle with radius 1 plus 3x centimeters is twice the area of the shaded region in a sector, which has an angle of 120 degrees and a radius of 5x plus 1 centimeters. Find the exact value of x. Now, before we tackle this question, let's look at the mean candidate score for a similar question that was asked in a recent GCSE paper. And as you can see, the mean score for this question was only 0.31 marks out of a possible 5, which is just 6% of the total marks. And of those students who were awarded a grade 9, they got 2.91 marks out of 5 on average. And so this was a tricky question for all students. So let's go back to the similar question and walk through it step by step. Okay, so we're told that the area of the circle is twice the area of the shaded region in the sector, and the lengths have been given in algebra. So that means we need to come up with an algebraic expression for both the circle and the shaded region in the sector, and then form an equation so that the circle is twice as big. Now, the area of the shaded region in the sector can be found if we can subtract the area of the smaller sector, which is here, from the area of the big sector here. So the area of the big sector is 120 divided by 360, which is a fraction of a whole circle, multiplied by the area of a circle, which is pi r squared. So we have 120 divided by 360 multiplied by pi multiplied by the radius, which is 5x plus 1, squared. And the 120 over 360 simplifies to a third, and the 5x plus 1 squared can be expanded. And so we get pi over 3 multiplied by 25x squared plus 10x plus 1. So now let's find the area of the smaller sector, which is 120 divided by 360 multiplied by pi multiplied by the radius, which is 2x plus 1 squared. And as before, the 120 over 360 is a third, and the 2x plus 1 squared, when expanded, is 4x squared plus 4x plus 1. And so we get pi over 3 multiplied by 4x squared plus 4x plus 1. And now that we've got expressions for the area of the two sectors, we can subtract the area of the small sector from the area of the big sector to get the area of the shaded region. So the area of the shaded region is equal to pi over 3 multiplied by 25x squared plus 10x plus 1 minus pi over 3 multiplied by 4x squared plus 4x plus 1. And we can now take the pi over 3 out as a factor to give pi over 3 multiplied by 25x squared plus 10x plus 1 minus 4x squared minus 4x minus 1. And then collect any like terms so that we're left with pi over 3 multiplied by 21x squared plus 6x. Okay, so this is the final expression for the area of the shaded region in the sector. We now have to find the area of the circle, which is a bit easier. So the area of a circle is pi r squared, and we're given the radius, which is 1 plus 3x. So we have pi multiplied by 1 plus 3x squared, and then expanding the brackets gives pi multiplied by 1 plus 6x plus 9x squared. And the question states that the area of the circle is twice the area of the shaded region in the sector. And so this means that 2 multiplied by pi over 3 multiplied by 21x squared plus 6x is equal to pi multiplied by 1 plus 6x plus 9x squared. And notice that the pi's on either side will cancel, and so we get 2/3 multiplied by 21x squared plus 6x is equal to 1 plus 6x plus 9x squared. And we can now expand the bracket on the left-hand side, which gives 14x squared plus 4x is equal to 1 plus 6x plus 9x squared. And now move all the terms to the left-hand side to give 5x squared minus 2x minus 1 is equal to 0. And because the question says that we need to find the exact value of x, this is a hint that we shouldn't attempt to factorize, but to use the quadratic formula instead, because the word exact means the answer should involve a surd. So we have x is equal to minus 2 plus or minus the square root of minus 2 squared minus 4 multiplied by 5 multiplied by minus 1 all over 10. And so x is equal to 2 plus or minus root 24 over 10. Now the root 24 can be split into root 4 and root 6. And so we get x is equal to 2 plus or minus root 4 times root 6 all over 10. And the root 4 is equal to 2. And so x is equal to 2 plus or minus 2 root 6 all over 10. And finally, we can divide everything by 2 to give x is equal to 1 plus or minus root 6 over 5. But because x has to be positive, as it represents a length, we can reject the 1 minus root 6 over 5, and so the final answer is x is equal to 1 plus root 6 over 5. Okay, so that's how you answer a tricky area of a sector question that's suitable for those students aiming for a grade 9. If you found this video helpful, please like it and subscribe to my channel where you'll find more aiming for grade 9 GCSE maths videos. Thanks for watching.